Well, good morning, everyone. It is 10:30, so we'll go ahead and get started. I just want to let you all know, for those of you that had taken the exam, that I have gone through and reviewed the work and updated the scores based on the partial work. Now, I do want to make a comment. I understand not everyone has a scanner. I really recommend downloading that CAM scanner app. And I've gone, just based on some of the issues we had with this one, I've gone up and we have a new set of directions that should be a little more helpful for the final exam. But it's really important because a couple people, and it's not bad, but a couple people did just send me pictures of their work, and it's really hard to read. And so there might have been some stuff I couldn't read that I couldn't give extra points for. I did the best I could. Trust me, like I said, I always try to eke out any points I can get for you guys. So I promise I did the best I could. But that CAM scanner app, a few people use that, and it actually does a really good job of making the document look much better than just taking a photograph of it. That's one. Two, I had provided the answer sheet, the same one that we use on the exam in class. I know not everyone has a printer. I completely understand. Just it's not something that everybody has at home. If you don't have a printer at home, that's fine. You can use scratch paper as long as it's blank and you show it to the honor lock proctor. That's fine. But you need to number all the problems and do them in order so that I can find the problem that corresponds to the answers you got, so that I can see where it went wrong. If you don't number everything, it's really hard to go through all the work and figure out where the problems are. So just remember that for the final exam. Um, the other thing is, I know honor lock is a huge pain. I get it. Like, it's trust me, it's not something that I'm a huge fan of. Unfortunately, it's a requirement for us. They've already had some issues at the school with like dishonesty in testing, and so it's something that we are required to do. So I'm going to keep working with you guys as much as I can. Again, I will be sending out newer instructions for the final exam. The thing is, you guys need to make sure you read the instructions before the exam. Don't wait till you start it and then get completely overwhelmed. Make sure you read through them, understand the steps, and then we'll just do the best we can. That's all anyone can do at this point. So like I said, I'll always be checking email and try to work with you guys. I did get to go through, so there's a few problems I did want to cover from the exam before we pick up with section 4.8. So there were 4 problems that seemed to give everyone a little bit more problem than the rest, and of course some of them were word problems. So this is from the exam 2 review that we went over the day before the exam. This is also the same as number 3.5, number 17. It's that Frisbee, or no, the number problem. So this one, we'll just go through it one more time to make sure everybody understands. So it says 47 less than some number is equal to the sum of 5 times the number and 5. Remember, when we hear 47 less than, that means we're taking 47 away from something. So that means that we're subtracting 47 from something, okay? It's not 47 minus something. It said, if I were to say, what's 2 less than 3? Well, I think everybody knows that that's 1, because we know 3 minus 2 is 1. It's the same idea. So when you hear 47 less than, you need to know that you're doing minus 47. All right, so it says 47 less than some number. So some number, that's x. So right now we already know that we have 47 minus x. That's gotten us up to, oops, right here. Now we see is equal. Obviously that's giving us the equal. And it says to the sum of. Now, a lot of people in this one started putting parentheses. Remember, the only time you put in parentheses is when you see something multiplied by the sum. So if I read 5 times the sum, that would need a parenthesis, or the division, or whatever, dividing. The other time is when there's a comma. The commas kind of tell you do whatever is in here first before moving on next. So when I see sum of 5 times the number, I go ahead and say 5 times the number and plus, because that's our sum, and 5. Another tip is when you see and, that's another word for plus, right? So this is the translation. Here's your translation of, oops, of course, of that word problem. But now we need to solve for it, right? So let's go ahead and solve. remember when we're solving, we have our 4 steps. We have simplify, we have our addition property, multiplication property, and check. So what we need to do is we need to get all the variables on one side and all the numbers on the other side. So let's start with our variables. And I like I've said before, I like to keep a positive numeric coefficient in front of x. You don't have to, it's just something I've always done. So in order to do that, we need to subtract x from both sides, right? We need to cancel this out. So that cancels that out. We're left with negative 47 on the left side. And then we're left with 5x minus x, which gives us 4x plus 5 on the right side. So now I've got all my variable terms on one side, right? This is right here. There's no other variable terms to worry about, but now I need to get those numbers on the other side. So I know since I have my variable term on this side, I need to get this number over here. In order to do that, I need to cancel it on this side. I need to make it a 0. And whatever I do to one side, I have to do to the other side. All right, so these now cancel. So now we have negative 47 minus 5, which gives us a negative 52 equal to 4x. Right, that's our addition property. Remember in our addition property, we're just trying to get these variable terms on one side and everything else on the other side, the numbers on the other side. So then in our next step, we need to now get this x all by itself. So in order to do that, I need to make this 4 a 1, right? Because I want to be multiplying 1 times x, which just gives me x. So I'm going to divide both sides by 4 to cancel that 4 out. And then negative 52 divided by 4 gives me negative 13. Oops, negative 13. So now I have x equals negative 13. And then we would check it by plugging it in. Does anybody have any questions about how to translate that or how to solve for that one? All right, remember, I've got you all muted just so that we don't hear a ton of background noise. But if you have a question, just write Q in the chat. I've got the chat up where I can see it. So just write a Q and I'll unmute you so that you can ask your question. All right, so let's move on to the next one that seemed to be a problem for everybody. All right, so that's the Frisbee score one. So this one is number 3.5.23. So if you want to go back and practice it, that's there. The total points scored in a game of Ultimate Frisbee between the North Dorm and South Dorm was 214 points. The North Dorm scored 28 points more than the South Dorm scored. How many points did each dorm score during this game? I saw a few people start with just dividing that number by 2, that 214 by 2. You can't do that because then even if you try to add and subtract numbers, it's not going to get you the exact answer. So let's take a look. We know that the total score, let's just write it, oops, total, it's not spelled with 2 L's. Equals, we're going to say North Dorm plus, well, we'll just write an N plus S, right? The North Dorm score plus the South Dorm score. And we know that the North Dorm right here scored 28 points more. So we also know that the total equals 214. And we know that North equals S plus 24, or excuse me, 28. 28, right? Because they told us this right here. The North Dorm scored 28 points more. That means that N equals S plus 28. So now what we need to do is have an equation with just one unknown variable. Well, we know this and we know this. So we can plug those in. So now we have 214 equals S plus 28 plus S, right? This was our N and this was our total. So let's go ahead and start solving. So we need to combine like terms first. S plus S gives us 2S. So now we have 214 equals 2S plus 28. That looks like a 5, doesn't it? That's why I usually only use X. All right. So now we need to get this variable term by itself. Remember, that's our addition property of solving for algebraic equation. This was our simplify step. This is our addition property. So in order to get this all by itself, we need to cancel this out on this side and get it over onto this side. So we're going to subtract 28 from both sides. And so that's going to cancel that out. And 214 minus 28 gives us 186. Let's come up here. So now we have 186 equals 2s. So now we're done with our addition property step. Now we need to move to the multiplication property step. And when we do that, we're trying to get that s all by itself. In order to do that, we need to divide both sides by 2 to get rid of that 2. Remember, what ends up happening here is it's 2 divided by 2, which is 1. 1 times s is just s. That's why this works. So we have 186 divided by 2 gives us 93 equals s. So we want to know now what the North dorm scored. Well, we have this. So then North is going to equal 93 plus 28, which equals, plus 28 equals 121. So now we have what each team scored. And let's double check that the total is 214. So we have 121 plus 93 gives us 214. So we know that that's the right answer. Does anybody have any questions about that one? Oh, I just realized my work. Why wasn't anybody telling me my work wasn't showing? I'm sorry, guys. This is the other half of that work. So we had the 186 divided by 2, where the 93 equals the South dorm, and the North dorm equals 93 plus 28. All right, is everybody okay with that? Okay, I'll take silence as a yes. Can you guys hear me and see the screen? Okay, thank you, Sarah, Shanna. All right, let's go through one more. Let's see. All right, this is the other one I wanted to go through. So this is when we need to find the lowest common denominator of the fractions using A, the listing multiples method, and B, the division method. This was one on the exam that a lot of people did have a hard time with. Even if they were able to get 1, they may not have been able to figure out the least common denominator. So I'm glad we're going to go through this one because it's important, especially since we're still working with fractions. All right, so this has -5/6 and 7/12. Let me make sure the whole screen's showing this time. All right, so we need to do listing multiples first. So I'm just going to write multiples. So when we list multiples, we just write the denominators next to each other, and we just start by writing the multiples. Some people wrote the factors. Some people wrote like numbers like the prime numbers. That's for the division method. So for this one, you just need to write multiples. So what's the first multiple of 6? It's 6. Then it's 12. Then it's 18. But we don't need to go down to this one because that's a 12. So we really can just stop right there. Right? And so since those are the same, that's our least common denominator. So once these are in common, you just stop right there. Now, I do want to show you guys one with a different number. This just as an aside, this is not from the same problem because I want to show it writing out a few more multiples. I just want to make sure this is really clear. Let's say we had, I don't know, 5. We're going to get a little bit farther. So here we have 6, 12, 18, if I have enough room, 24, 30. Well, I know that 30 is a multiple of 5, so I know I can stop there. If you don't know that, then you just come over here and write it until they match. So we have 5, 10, 15, 20, 25, oh, 30. See right there, they're the same. That means the least common denominator between 6 and 5 is 30. Okay, I just wanted to write that out just to make sure it was really clear because that the 6 and 12, you only write a few little bits. All right. So let's go ahead and rewrite it just so everybody's got it, 12. So the least common denominator is 12. Now let's do the listing or the division method. So the division method, we have 6 and 12. And remember, we start with our prime numbers. This is where you use your prime numbers. Now, 6 and 12, can I divide them, either one of them by 2? Yes, both of them. So let's go ahead and divide by 2. 6 divided by 2 gives me 3. 12 divided by 2 gives me 6. Can I divide either one of these by 2? Yeah, not the 3, but I can divide the 6 by 2. So I'm going to keep going with 2. Now that 3 is not divisible by 2, so I just carry it down. The 6 is divisible by 2, and I get 3. All right, now I can't divide by 2 anymore, so now I need to move on to 3. So 3 divided by 3 is 1. 3 divided by 3 again is 1. So I'm done because I've gotten 1 and 1 here. So now my least common denominator equals 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. So now you see it, and they should agree. That's the other thing. If you get different answers in these, there's something wrong somewhere. You should always have the same least common denominator no matter how you get there. Any questions about that? How to find the least common denominator? And I want to make sure it's clear because we are still working with fractions. That's not gone away. We will, oh, everyone, because Shannon, you're good. We will be working with decimals in the future, but for this last section, modules 9 and 10, I believe, we're still working with fractions. So it's really important that you guys understand this. All right, let's move on. Okay, so that's it for the exam. Did anybody else have any exam questions or concerns or anything they wanted to ask me about the test? Okay. No, thank you. Thank you. I do appreciate some response because like I said, I'm sitting here talking to a computer screen and sometimes it's hard to know if you guys hear me or if I'm getting cut out. So if you guys can even just say no or write yes, no, whatever, that would be very helpful. I appreciate that. All right, so let's go ahead and move on. We left off last section. I know, Sarah, I'm with you. Oh, you wish the test wasn't timed. I do understand that. It does add a little bit of stress to the situation. But the idea is that that's how long we would have had in class. But I do, you're not alone in that, unfortunately. All right, so last week, does everybody remember this that we went over in 4.8? Simplifying fractions that contain variables. Do you guys remember this? Yes, thank you. All right, so we left off with some of these examples. Let's go through them just to make sure it's really clear because this is a really important concept. So we're going to go down to part B here and your turn on page 105. So let's go ahead and go through just a couple of these just to make sure. So we have 8a over 40ab. Okay, so does anybody remember what we need to do to start this? All right, what we need to do to start this is to write out our factors. So remember our factors, remember we write down, so we have in this case, we have 2 times 2 times 2 for 8. And if you don't remember that, you can just write out your little factor tree. 2 times 4 and 2 times 2. But I know that 8 is 2 times 2 times 2. All right. And then our other factor is A. On the bottom, excuse me, we have 40. Well, let's look at 40's factors. We have 2 times 20, 4 times 5, 2 times 2. And those are the prime numbers, so we're done there, right? So we're going to have 2 times 2 times 2 times 5 times A times B. All right, and then what we do is we just take those prime factors and we start canceling them. So this 2 cancels this 2 cancels this 2. And remember, the idea is this right here equals 1. This right here equals 1. This right here equals 1. So if all these equal 1, it's like saying 1 times 1 times 1 times this that's left over, right? So that's why it cancels, because they just equal 1. All right. And then there's nothing else there's no other numbers, so that 5 is going to stay there. This A cancels this A. So remember, that's 1. So then we also have a B. So all we have left on top is 1, and all we have left on the bottom is 5B. So that's how you can cancel it out. The other way you could cancel it out, let's look at it down here. This is the way I think of it personally too. We have 8A over 40AB. You could say, wow, I know that 8 is a factor of 40. So you could divide 8 out of the top and bottom. So that's going to give you A over 5AB, right? Because 40 divided by 8 and 8 divided by 8 gives you 1 and 5. And then you can say, oh, I know those A's cancel. So that gives me 1 over 5B. Now, if this is something you should strive to get towards, but if that is not clear to you, this is okay also. That it's just, this is a quicker way to do it. And this is kind of how we did it with numbers. Remember, we started just pulling out factors that we recognized. But if it's hard for you, don't do it that way. But this is a quicker way, especially if you recognize those factors right off the bat. Even if you don't, even if I just looked at it and said, oh, I know that it both divide out of 40. Let's say I just, or 44, excuse me. I could say, oh, I know that's divisible by 4. So that's going to give me 2a over 10ab. Oh, I know that's still divisible by 2. I could say 1 over 1a. We'll just leave it as 1a. 1 over 5b, ab. Gosh darn it. Over 5ab. And then those a's cancel, 1 over 5b. Again, it's not an exact science. It's just if you start recognizing factors, you can pull them out. That's the step. So either way is fine, whatever you're more comfortable with. But and either way, this is your answer. All right. Okay, well, let's just clear that whole page. All right, let's go down. So let's look at part C real quick. And then I want to do one more of these. So we have 48 xy squared over 2. Don't worry, I'm going to move the screen in a minute. Again, if I forget to go to the, oh, I thought you had to divide top into the bottom, Sylvia. I thought you had to divide the top into the bottom. Can I unmute you, Sylvia, just to make sure because I'm not understanding your question. All right, Sylvia, go ahead. You're unmuted. Sylvia, can you explain what you meant by that one? I'm going to write it back up here.
I thought you had to divide the 8 into the 40.
Well, that's what I was doing. Well, okay, so no. This is the same thing as saying 8a divided by 40ab. Is that what you mean? Actually, 40 is dividing into 8.
No, I actually thought you'd take that 8 and actually divide it into the 40, not with dealing with the A and the AB.
Well, you have to. You can't ignore the A and the AB. Is that what you mean?
I think so. It's just confusing because, like I said, I'm sorry.
No, are you talking about when I write it like this?
No, the way I did it, I took the 8 and actually divided into the 40 itself. I didn't deal with nothing with A and AB.
You just said 8 divided by 40.
Yes, that's what I thought you had to do.
Well, that's part of it. That is part of it. 8 divided by 40 is part of it, but that's 1/5, right? Is that
right?
Back to the 5? But then were you able to cancel the A's after that?
I don't know how you. That's the only thing. I don't know how you do nothing about canceling anything. I honestly don't.
Well, that's why I'm showing it. So it's really important that you see this step. So if we were to do that, let's say you just said 8 over 40, and then you multiply by A and multiply by AB. So even if you ignore this part, let's just ignore that for now. I'm not canceling, I'm just ignoring it for now. You look at this, A divided by A, that cancels because it's a 1. If you have 2 over 2, that equals 1. If you have A over A over, how do I write one thing and say one thing? A over A equals 1. So that's how these cancel. So that's why it's important to write out those factors. Does that make sense? Because this number,
it does.
8 over 40, let's say you had something like, let's just look at a totally different example. Let's say I had something like, let's just say I had 2x squared y over 3x y squared. Okay? These numbers, you're not going to reduce these any further because they're prime numbers. They don't divide into each other, right? So you still need to know that you need to do 2 times x, because remember x squared is x times y, and 3 times x times y. So you need to write out your factors. If you have a hard time doing this like quickly, you need to write out your factors. That's the best way to do it. And when you see these numbers like this, you can start canceling. Anytime you have the same thing over itself, whether it's variable or number, that equals 1. So this right here, that y over y equals 1. So those cancel. So then you end up with 2x over 3. And that's what's left, because that's all the factors that are left on there. You have 2x, which gives you the 2x on top, and then you have a 3 here. So that gives you your 3 on the bottom. Does that make a little bit more sense?
I think so.
Okay. Does that help anybody else to go through that a little bit? Okay. Thank you. Good, good, good. All right, and then Sarah, you asked about an improper fraction. Were you referring to this, the examples here, or are you talking about just numeric improper fractions? All right, Sylvia, I'm gonna go ahead and mute you. Sarah, do you want me to unmute you so you can elaborate on that question a little bit more? Yeah, hold on, let's go back. Sarah, I'm gonna unmute you. Can you go ahead and tell me what you mean by that? Sarah, can you hear me? Go ahead and talk if you want, just so you can tell me a little bit about what you mean by that question. Oh, I can't hear you. Maybe your speaker's not working. So are you just asking about improper fractions numerically? Okay, I'll explain that. Okay, maybe you and I can pull that off later and talk later about that, okay? All right. All right, so let's go back and do one more of these examples and then we'll move on. So we're looking at part C down here on your own. So I wanna go through this one because it's got a lot of ugly numbers. Everybody loves ugly numbers, right? All right, so we have 14a to the 4th, b to the 3rd. And I think, Sylvia, this might help you too to go through some bigger, uglier numbers. ab squared. So again, let's go ahead and go through all of our factors. So for 14, what are our factors? We have 2 and 7, those are prime, so that's it. For 35, we have 5 and 7, and that's it. Okay, so let's write those out here. So we have 2 times 7 times a, oops. Let's do this. Times a, times a, times a, and then I'm not gonna make this fit. I'm working on this tiny little iPad, well, not tiny, but a little iPad. 2 times 7 times a, times a, times a, times a. We have b 3 times, right? So that gives us that a to the 4th, 1, 2, 3, 4, and b to the 3rd, 1, 2, 3. That's the top. The bottom then we have that 35 is gonna give us 5 times 7. We have 1a and 2 b's. So the 2 and 5 don't cancel. But that 7 is a 1, right? That cancels. 1a cancels, and we're left with the rest of those a's. We have a b that cancels and another b that cancels. So we're left on the top. If you go along, we have 2, and then we have 1, 2, 3 a's. So that's a to the 3rd, and then we have 1b. And on the bottom, all we're left with is 5. What page, Joy? We are on page 105. All right. All right, so we have 2a cubed times b all over 5. So that's how they cancel out. You just literally write out all your factors, and then you can cancel them out. Now, one thing I do want to point out, for anyone who's like getting this pretty well and it's pretty easy for you, not pretty easy, but like pretty clear, the other thing you can do is just look like we were talking about. So let's look at this one, 14a to the 4th b cubed over 35ab squared. Now, some of you may have noticed that you can also take this exponent and subtract this exponent, and that's what you're going to be left with. So we have, and we already know that 14 and 35 are both divisible by 7. So we're going to divide by 7 and divide by 7. So that leaves us with 2 on the top and 5 on the bottom, right? This a to the 4th, remember when we have nothing up here, when there's nothing, no exponent, that's the same thing as being to the 1st power, right? So 4 minus 1 gives us a to the 3rd. And b, 3 minus 2 gives us b to the 1st. Now, if I ended up with a negative exponent, let's say that I had, this is just an example, and if you're having a hard time with this stuff, ignore me right now. Okay, let's say I had a 2 and a 3 here, so it was B. 2 minus 3 is -1. That would mean that I would be left with B on the bottom. Okay, but again, if you're having a hard time with this, do not worry about that. That's just a shortcut for anyone that's grasping this pretty easily, okay? But for the rest of us, let's focus on writing out those factors and canceling them out, okay? Any questions about that? Joy, I'm sorry, what was, do you want me to, can you unmute yourself to tell me what your question is?
Can you hear me?
Yes, go ahead.
Okay, could you do, was it 14A at the top again? How did you get to 2? Okay. The
14.
2,
Okay. Oh, I see.
you know what can we do? Go back to the other sheet you just pulled up.
Yes.
This, wait, what was that? Is it that one? Yeah, okay. I'm late. Could you show me how you got that again, please?
Okay. All right, so we need to write out all of our factors. So we start with 14. We have 2 and 7. Those are our prime factors of 14.
Right.
35, our prime factors are 5 and 7. Right? So then we rewrite these two, the top and the bottom, as prime factors. So we're going to write out 2 times 7, and then this a to the 4th becomes a times a times a times a. Right? We have a to the 4th. That's the same thing. And then we have b 3 times because we have b to the 3rd. Then we write our bottom. We have 5 times 7. That's our 35 becomes 5 times 7. So we're writing it as prime factors times a, and then we have b squared. So this 2 and 5 don't cancel, but these 7s cancel. These a's cancel. These b's cancel, and these b's cancel. So then we rewrite what we have left. So then we have 1, 2, 3 a's, so that's a cubed, and 1 b. And on the bottom, the only thing we have left is 5.
Okay, that helped.
That helps. Okay, good. All right. I'm going to mute you back. Again, if you have questions, just write Q or let me know, and I will unmute you, and we can go from there. All right, so let's erase this. All right, so now we're going to talk about how to multiply or divide fractions that contain variables. So again, we're going to need to use our simplifying and reducing skills that we just learned so that we can do this. So earlier in this chapter, we learned how to multiply or divide fractions containing only numbers. Now we'll apply the same process to multiplying or dividing fractions that contain variables. Here's an example of multiplication, and what I like is it shows it with the number example next to the example with variables. So you can kind of see how the number part we keep the same. It's just the variables we're adding in. So here's the number fraction, and here's the same number, but here now we're adding in variables. So first you multiply the numerators, then you multiply the denominators. So here we had 2/3 x times 3/7. So again, it translates to 2 times 3 over 3 times 7. On this side, we had 2x over 3 times 3 over 7x. So now we have 2 times x times 3, and then 3 times 7x. And down here, see how they canceled out those 3's? Remember, because 3 divided by 3 is 1, so that those become 1s. And then here, the x's cancel, and the 3's also cancel. So all we're left with both is 2 7s. All right, and again, that'll make a little more sense. We'll go through some examples. So the process when you just have numbers without, this is the one when you contain, how to multiply fractions that contain variables, the same exact thing. Multiply the numerators and then multiply the denominators and then simplify. Again, we just go straight across. And then how to do it, how to divide it, we do the same thing. We switch it to a multiplication problem. Remember, same dot flop, and then just multiply across the top. When multiplying or dividing, treat variables the same way you treat numbers. When multiplying, simplifying can be done first if it makes sense or it makes the problem easier. So in this example, before multiplying, we see that 4 and 2 have the same factor. You'll see me do this pretty often. So you end up with 4 divided by 2 is 2, and 2 divided by 2 is 1. So now we just have 2x over 7 on the bottom, because then we just multiply across. When dividing out common factors, divide out from a numerator and a denominator, not a numerator and another numerator, or from a denominator and another denominator. Remember, always remember that fraction bar is your balance. It's like the middle of your teeter-totter, right? You got to keep it balanced. So whatever you do to the top, you do to the bottom. You can't do it to 2 tops and you can't do it to 2 bottoms, because then you lose that balance. Remember, no common denominators are needed when multiplying or dividing fractions. When dividing, always take the reciprocal of the second fraction. That's that same dot flop. When dividing, the simplifying cannot be done as a first step, because you're going to end up switching it when you multiply. So you always have to switch it to a multiplication problem first, then simplify. Some students find that simplifying easier when they divide out common factors from the numbers first, then from the variables. So it just depends. Again, I'm going to show you the ways that I always think it's easiest, but if you see something that works better for you, that's fine, as long as you're following the appropriate steps. So don't feel like if the way I'm, like the order I'm doing it in is confusing. All right, so let's go down here. We're on page 107, part A. So we have negative 4 over 15y divided by negative 8 over 3y. Well, we know right off the bat, since we have a negative and a negative, the answer is going to end up being positive. The first thing we need to do is switch it to a multiplication problem. So that starts us with negative 4 over 15y, same dot flop over 8. I definitely see some common factors or some simplifying we can do here. So this 4 and this 8, remember top and bottom, even though it's a cross because we're multiplying, it's okay. So 4 divided by 4 gives me 1, and 8 divided by 4 gives me 2. I also see that this 15 and 3 have a common factor of 3, so I can divide 3 by 3 gives me 1. 15 divided by 3 gives me 5. And I see that those y's also cancel, right? Y and y are both going to end up being 1. So now I just have to multiply across the top. So right here I have negative 1 times negative 1 is going to give me a positive 1. And on the bottom I'm left with 5 times 2, which is 10. So did anybody else think that when you saw this big ugly problem that you'd end up with something so nice and simple like 1/10? Yeah, that's see, just take it one, like I said, all you gotta do is just take it from little steps and just keep going and work in order. Because the nice thing about these problems, they're not like real world problems. You usually get like a nice answer. All right, let's look at part B. We have negative 5a over 4b squared times 7b, oops, gosh. I'm not gonna lie, like the Apple Pencil, it's awesome. I love that I have it, but it's not perfect. 7b cubed over 100a squared. All right. So this is a multiplication problem. So we don't have to switch anything. We're just multiplying across. But remember, we can start cleaning it up now, right? Oh, you can't. Thank you, Sarah. Sorry, guys. Thank you so much. So now we can start canceling some stuff out now because we don't have to switch to, can you post your notes when you're done? Yes, Joy, we can talk about that later, okay? Yeah, I'll be posting. I'm supposed to be posting a recording. Let's hope it works this time. All right, so let's go ahead and start pulling out some factors. So we have 5 and 100 have common factors, right? What about 4 and 100? They have common factors. Can I cancel out stuff between 4 and 100 here? Can anybody tell me if that's something I can do? Yes or no? No, you're right, Joy. We can't because it's bottom and bottom. We can only do it from top and bottom. So 5 and 100, let's see. 5 divided by 5 is 1. 100 divided by 5 gives me 20. Are there any other common factors that you guys see? Does anybody else see any other factors that we can start canceling out? No. I thought you had to flip it. It's already multiplication, Kim, so we only have to flip it when it's division. Okay, so we don't have to flip it. Yeah, that's only when we start with division. So there are no more numeric common factors, but what about variables? We have some variables we can cancel, right? Remember? Now we can do it at the end too, but yeah, we can talk about that. We'll go ahead. Do you guys want to multiply it out and show the factors? Would that be easier, do you think? Yes. Okay, so let's go ahead and do that. So let's multiply the numbers out. So here on the top, we have -1 times 7. So we're getting -7 times a times b cubed, right? That's the a and the b cubed. Now on the bottom, we have 4 times 20, which gives us 80. And then we have a squared times b squared. Now, we already know that those numbers are as simplified as they get. 7's a prime number and it's not a factor of 80. So we don't have to mess with canceling out the numbers at all. But we do need to mess with the variables, right? So let's go ahead and write those out. So we have -7a times b times b times b. And then we have 80 a times b times b. So that a cancels that b cancels that b, and that b cancels that b. So now we're left, on the top we have -7b left, and on the bottom we have 80a, and that's it. So do you see how like there's even a combination? Like I could have probably gone through and canceled this out a little bit sooner just from my knowledge, but you guys weren't comfortable with it. So we just did the number part here and then the variables here, and that's okay too. The idea is you just need to make sure that your final answer is as simple as it gets and that there's nothing on the top that could cancel out the bottom or vice versa. All right, let's go through another example. So we're on your own. Let me write this and then I'll try to remember to show you guys the screen. We have 2z over 5 times 3 over 4z. All right. All right, so I see one factor right off the bat, that 2 and that 4, right? So 2 divided by 2 is 1 and 4 divided by 2 is 2. Anything else? Does anybody else? Wait. Joy, this whole recording is going to be uploaded, so just write what you can, okay? So we're right here, we're at 2z over 5 and 3 over 2z. Does anybody else see a common factor that we can pull out? No? What about z? Does anybody see it, a variable that we can easily cancel out here without writing out the factors? Because right, we have z divided by c and z divided by z, right? That one's pretty easy because we're not dealing with the a squared and b squared and z squared stuff. So here we have 1 times 1 times 3 on the top, which is just 3. And on the bottom, we have 5 times 2, which is 10. Does everybody see that and understand that? Okay, good. All right. Let's go to this last example in this. We have 12x squared y divided by 4xy over 3z. Now, one thing that we need to remember, and they put it right here so kindly in the little bubble, is that 12x squared y is the same thing as 12x squared y over 1. So it's really important to make sure you have them in the same fraction form just so that you don't lose track of what needs to be multiplied to what. So we're going to start by writing this as 12x squared y over 1. And then what do we need to do to a division problem? We need to switch it to multiplication. And Kim, that's what you were asking about earlier. Because this is division here, we need to switch it to a multiplication problem. So when we do that, we keep it same dot, change to multiplication, and flop 3z over 4xy. Everybody okay with that part? Kim, thank you, thank you. Sorry, guys. Gosh. So same dot flop. So we kept this the same, switched this to multiplication, and then took the reciprocal of the second fraction. All right, so let's go ahead and look at some common factors. That 12 and that 4 are common factors, right? So we have 12 divided by 4 is 3. 4 divided by 4 is 1. And I don't see any other common factors from the top and the bottom. So we're done with the numbers. So let's go ahead and write what we have left. We have 3 times 3 on the top, right? And I'll go ahead and write it out. We have 3 times 3, and then we have x squared yz over xy is all that's left on the bottom. Let's go ahead and write that out a little nicer. We have 9, and then we're going to go ahead and write out our factors. So we have x times y times z, all over x times y. Ugh. All right, so we have this x cancels this x, and this y cancels this y. So all we're left with is 9xz over 1, which is actually just 9xz. So that's what you would write as your final answer, 9xz. Okay? All right. So now we're going to talk, I think this is the last part in section 4.8. We have, I believe, we have, now we're going to add or subtract fractions that contain variables. So now we have, earlier in this chapter, we learned how to add or subtract fractions containing only numbers. Now we'll apply the same process to adding or subtracting fractions that contain this is, Sylvia, this is so confusing. What part's confusing? Like how to cancel them out? Okay. Why don't you and I talk after class? You agree, Joy? Okay. Let's take a quick look at something. Let's look at that part B. Maybe that one will make it. Let's just go through one more, and I'll try to explain it a little bit different way. Okay, so we have 15x over 8 and 18 over 5x squared. Okay. So let's think, we know that we can like cancel out factors, right? Do you guys understand the number part where we're pulling out numbers? Yes. Okay. So when I say that I can cancel this to 3 and this to 5 because I can pull 5 out of both, that's okay. Okay. All right. So now let's look at the number part on this one. We have 8 and 8. Both of them have a factor. They can both have a common factor of 2. So let me go ahead and pull 2 out of both of those. That gives me 9 and 4. All right. So now just multiplying across the top, we have 9 times 3, which is 27x, because we still have that x there. And then on the bottom, we have 4 times 5 times x squared. So that's going to give me 20x squared. So the number part's done because we already simplified the number factors. Factoring. Well, what do you mean by factoring, Joy? Like we're pulling out factors. Yes, if that's what you mean. Yeah, we're pulling out factors of the numbers, right? 5 is a factor of 15 and 5. 2 is a factor of 8 and 18. Okay? I just see that they have common factors. Like I look at 18 and 8 and I know that they're both even numbers, so I know they at least have 2 in common as a factor. And 5 is a multiple of 15. So I know that those are common factors. But since we already simplified all the way here and we know that there's nothing else to simplify here, we're done with the number part here. So all that we have to worry about is the x part. So we're going to write 27x on the top, and then on the bottom we have 20x times x, right? 20 times x times x. This x divided by x, that's the same thing as 1. So if that's the same thing as 1, we might as well get rid of it, because that's like when you multiply 1 times anything, it's the same. So since that cancels out, all we're left with is 27 over 20x. So the idea is if you need to just write out all the factors. The other way to do this, let's say you don't see any of those common factors. The other way to do this, well, I guess I should just erase the whole stupid thing. Let me write this over again. We have 15x over 8. 18 over, oops, 5x squared. Now, you can do this the long way. It's a huge pain, but let's go ahead and just write out the multiplication. Let's say you didn't cancel anything else out. You're not pulling those factors. You're canceling. You are basically pulling them out of the top and the bottom. Okay, if that makes more sense. So here we have 15 times 18 times x on the top, 8 times 5 times x on the bottom. So let's say you don't know how to cancel anything out in this step. This is what we're getting at, right? We're multiplying this all out. But at this point, you can start pulling out those factors. So here I know that 15 and 5 are both divisible by 5. Now, if I don't remember that, I can multiply all this out, but you're going to get these huge, ugly numbers that are harder to work with. Like on the top, it would be 15 times 8. So you would have, let's say I didn't know, it would be 270x over 40x squared. And then you'd have to go through and factor 270 and factor 40 and write out all of their prime factors and then go through to cancel. And that is very time consuming. And it would take you way too long, especially to find all your prime factors of 270. That's a huge pain. Well, it's not huge. It's just a lot of numbers. You'd end up with, you'd have like this, 10 times 27. Then you'd have 3 times 9. Oops. 3, 3, 2, 5. So that's a lot of factors to write out and mess with canceling. So just to me, it makes so much more sense. And that's the end goal, is that you need to get to a point where you can look at this and start canceling these numbers out. Okay. So on this one, I see that 15 and 5 have the same common factor. So if I say, okay, 15 divided by 5 is 3, 5 divided by 5 is 1. Now I look at this, I go, okay, well, 8 and 18 are both even. So I know they're both divisible by 2. That's too, yeah, it is too much, right? It's a huge pain. So if I know that 8 and 18 are both divisible by 2, I can say this 18 divided by 2 is 9, and 8 divided by 2 is 4. Well, these x's cancel because x over x equals 1, so that's done. So then I'm left with 3 times 9, which is 27. And then on the bottom, I have 4 times x. And that's it. Okay? Does that help a little bit for anyone having a hard time with that? Okay, good. Listen, and if you're if you're having a hard time, practice it. You need to practice and force yourself to learn these steps. Don't just use the calculator and guess what the answer is. You have to make yourself do it, or you're never going to get it. So make sure you're doing the practice problems over and over again until you understand it. There is free tutoring available. That's what I want to reiterate. If you email the tutoring coordinator, Jasmine, she's in our class, so you can find her email address, Jasmine Carter. She can help you set up a one-on-one tutoring session. So please reach out. You can ask me questions, whatever. So make yourself figure this out. Like, go through and practice it, okay? All right, so let's go back down here. We're going to pick up where we left off with adding and subtracting fractions. So here we have the same exact method, but now we're just adding variables in. So when you have these ones that have the same denominator, so you don't have to do anything with the denominator, finding a least common denominator. Okay, Sylvia, why don't you and I talk after this, okay, Sylvia? You guys both contacted the tutor and it's still not working? Okay, let's talk after class then, okay? All right, so listen, here we have to add or subtract fractions that have the same denominator. We add or subtract their numerators and keep the same denominator. Treat variables the same way you treat numbers. So in this example, you add the numerator and keep the common denominator. Again, these are only problems where you have the same denominator. So here you have 3 7s plus 1 7. Remember, you just add the numerator, 3 plus 1 over 7, which gives you 4 7s. This is the same, but now we have a variable. So look, we have 3 over 7 plus x over 7. You keep your denominator the same, and you just add 3 plus x. Now, we can't simplify here because you can't combine 3 plus x, so that's where you leave it. So to add or subtract fractions that have different denominators, you must find the least common denominator, then add or subtract. So in this case, we have 2 over x minus 5 over 6. Well, we need to find the least common denominator of 6 and x. Now, we know that it's 6x. There's nothing there that you can find that's more common, but they showed here how you can even do it with the, this is the factorization method. So we'll go through some examples and you can see it more clearly. So in this case, we have, in order to make this x on the bottom a 6x, you have to multiply top and bottom by 6. And in order to make this 6 a 6x, you have to multiply top and bottom by x. So now you have 2 times 6 on the top, which gives you 12. And then over here you have 5 times x, which gives you 5x. So we have 12 over 6x minus 5x over 6x. Then you subtract across the top, 12 minus 5x, all divided by 6x. And if there's anything else you can simplify, but in that case, there's nothing else to simplify. So if the fractions have different denominators, find the lowest common denominator, and then rewrite the fractions as equivalent fractions with the lowest common denominator as the denominator, and add or subtract the numerators. Keep the common denominator. Do not add or subtract the denominators. You only add or subtract the top, and you leave the bottom the same. And then simplify the final answer. Make sure the fractions have a common denominator before you add or subtract. Find the LCD, factor the denominators, and make a product using each factor the most number of times it appears in any one factoring. Take the time to find the least common denominator. Do not find a common denominator just by multiplying the 2 denominators together. This method does not work well with algebraic functions that you may study later. Do not simplify any fraction before the final answer. Otherwise, you'll be undoing the right equivalent fraction step. So let's go down here. On your turn, we're on page 109. And let's start looking at part A. So we have negative 2a over 7 minus negative 5 over 21. Well, the first thing we need to do is, one, we know this is actually an addition problem, right? Because when we subtract a negative, that's an addition. And then what's our common denominator? Does anybody see it just by looking at the problem here? 21, very good, Shannon. Remember, when one is a multiple of the other, this is our common denominator, since 7 is a multiple of 21, or a factor of 21. I shouldn't say multiple, a factor of 21. All right. So in order to make this fraction have a denominator of 21, we have to multiply the bottom by 21, or by 3, and then we have to do the same to the top. So what's 3 times negative 2a? That gives us negative 6a over 21. And remember, this is the same as addition when we're subtracting a negative. So we're going to add 5 over 21. Everybody okay there so far? All right. So now we have negative 6a plus 5 over 21. Because we add the top, but then keep the bottom the same. We don't add the bottom. Can we simplify that anymore? Okay, 24. 2a. What can we simplify with 2a? Sorry, that's okay. Yeah, but we can't simplify it. No, you're right. We cannot. No, that's okay. We can't simplify that though, because we can't combine it with the 5. Because we can't combine these two terms because they're not like. This is as simple as it gets. So this is simplified. No, that's okay though. That's good. I'm glad you're thinking about it. All right. All right, let's move on to the next one. So here we have one now where we have y in the bottom. So we need to figure out how to come up with a common denominator when there's a variable. So we have 4 over y plus 4 over 11. Any ideas what our common denominator is going to be? It's going to be 11y. So let's go ahead and look at it this way. We're going to do the factorization method. Y equals y, and 11 equals 11 because they're prime. So we take it from wherever it occurs the most times. So 11 occurs the most times here. So that's 11 times y, because y occurs the most times there. So our lowest common denominator is going to be 11y. So we have to multiply this by y over y to make that bottom 11y. And then we have to multiply 11 over here to make that bottom 11y. So now we have 44 over 11y plus 4y over 11y. And then we just add across the top. So we have 44 plus 4y all over 11y. And there's nothing else to simplify here. You could split this up into other fractions and simplify, but then we're just reversing that work. So this is simplified. There's no numbers in common or factors in common in the whole thing that we can simplify further. All right. All right, let's go down, do part A. So we have 8 over x plus 2 over x. These have a common denominator, so we don't have to do anything to change the denominator, so we just need to add across the top, 8 plus 2 over x. Is that simplified? Or can I add those numbers on top? We can add those numbers on top, right? So we get 10 over x. Now that's simplified because those are like terms. Very good, Joy. Very good. All right, let's look at part B. We have 5x over 7 minus 9 over 10. All right, we need to find a common denominator. Did I write that down right? 9 over 10. Yes, okay. We need to find that common denominator. Well, let's go ahead and do the division method. So we have 7 and 10. And we're going to write our prime numbers. Oops. Helps if I actually write the prime numbers. 7 dot dot dot. So we need to start with 2, right? Because 2 is divisible by 10. So we have 7 and 5. Neither one of those is divisible by 2. Then we have 5 comes next because neither one's divisible by 3. We carry the 7 down. 5 divided by 5 is 1. Now we're done with 5. We go to 7, 1 and 1. So our lowest common denominator equals 2 times 5 times 7, which equals 70. So in order to make that 10 a 70, we have to multiply top and bottom by 7. And then we have to multiply top and bottom by 10 over here. Okay. All right, so now on the top over here, we have 50x over 70 minus 63 over 70. So now we subtract across the top all over 70. All right. And there's nothing to simplify there. Yeah, because there's no common factors with 50 and 63. So there's nothing we can do. So that's simplified. All right. Everybody kind of okay with that? Kind of ish, a little bit. Let me go ahead and, yeah, I'll take it. Let me go ahead and give you guys the practice problems for 4.8. I'm going to put them up on the screen. I'll be posting them when I post the recording later. So we have numbers 15, 19, 29, 31, 49, 51, 61, and 65. All right, so that's it for the module 9 material. We are going to get started. We have about 15 minutes. We do need to get started on 4.9 for module 10 because we need to kind of catch up a little bit with some of this stuff going on. So let's go ahead, and that's 4.8. Again, that's module 9. Module 10 is going to be 4.9 and 4.10. So let's go ahead and get down to 4.9. So now we're going to talk about deciding whether a fraction is a solution to the equation or not. So we already talked a little bit about replacement. We've talked about lowest common denominator. We've talked about all this stuff, and we're going to put all those parts together to solve algebraic equations. For now, though, we're just going to decide if it's a solution. Remember, to decide if something's a solution to an equation, no, it's okay, Joy, I promise it'll be fine. When we do that, we plug the number in for the variable, usually x, and then we see if both sides of the equation equal one another. If they equal one another, it is a solution. If they don't equal one another, it's not a solution. So decide whether a fraction is a solution to an equation, we'll use the same process we've already been using. So in this example, is 7/9 a solution to the equation x minus 5/9 equals 2/9. So you plug in 7/9 for your x, and then remember they have a little question mark over the equation, the equal sign. So then you go ahead and do the math. So when here they have a common denominator, so you choose 7 minus 5 over 9 does equal 2/9. Since 2/9 equals 2/9 is true, that means that 7/9 is a solution for this equation. So the process is that we replace the variable with the given value, simplify both sides of the equation. If the final statement is true, the value is a solution. If the final statement is false, it is not a solution. Soon we'll learn how to solve equations containing fractions, but for now we're just going to focus on testing whether or not the value is a solution. So let's go down here. We're on your turn on page 115. So they're asking, is -1/6 a solution to -7/20 divided by x equals 21/10? All right. So remember, whenever we have x, just like a whole number, that's the same thing as saying x over 1. So it's really important to remember, especially when we're dealing with division, because we're going to be multiplying by the reciprocal, remember? So the first thing we need to do here, well, you know what, I take that back. Sorry, let's ignore that because we're replacing with a fraction. Just ignore what I just said. Let's go ahead and plug this value in for x and then go from there. So we have -7/20 divided by -1/6 equals question mark 21/10. All right, so to what I was just saying, we need to take the reciprocal. We need to switch this to a multiplication problem. So that means that we're going to do the same dot flop. Right, so now we have -7/20 multiplied by -6. So we need to see if that is equal or not. So I'm going to tell you right now, I don't know, but I do know that I have some common factors. So 6 and 20 are both even. So I'm going to reduce that to 10, and I'm going to reduce that to 3. It's looking pretty good that this is a solution. So now on the top on this side, I have -7 times -3 gives me 21, and I have 10 times 1, which gives me 10. And that does equal 21/10. So this is a solution to this equation. Okay? Again, it's the same thing we did with integers, but now we're just dealing with fractions. So you replace it, simplify both sides, and see if they're equal. So let's do another example. We have part B. Is 1 a solution for 2/3 minus x over 2 equal to 5/12 plus, x over 4? All right, so the first thing we need to do is replace. So we have 2/3 minus 1/2 equals question marks. We don't know if they're equal or not. 5/12 plus 1/4. Well, what's the first thing I need to do? Can somebody tell me what the first thing I need to do is? Because we do not have common denominators. We need to find the LCD, right? So we need to find the LCD on this side, and we need to find the LCD on this side because we're solving both sides. So I do see that 4 is a factor of 12. Since 4 is a factor of 12, I know my LCD on this side is 12. This is not as easy. That one I need to do something. Let's go ahead and do listing multiples for 2 and 3. So we have 2, 4, 6. Oh, I know that's a multiple of 3, so I think I'm good there. So 6 is my common denominator on this side. Okay. So on this side, I need to multiply 3 by 2 to make it 6. So I have to do it to the top and the bottom. And on the bottom, I have to multiply top and bottom by 3 to get 6. So let's go ahead and write out that side real quick. Not this whiteboard. All right, so we have 4 over 6 on this side minus 3 over 6. Now, over here, that 12 is not going to change, right? Because 12 is the lowest common denominator. But I do need to multiply that 4 by 3, and that means I need to multiply the top by 3 also. So now I have plus 3 over 12. All right, so let's start doing the math. So remember, when you have the same denominator, you just subtract or add the top. On this side, we have 5 plus 3 over 12. Let's come up here. So now we have on this, the left side, we have 4 minus 3 gives us 1 over 6. And on this side, we have 5 plus 3 gives me 8 over 12. Well, how do I simplify 8 over 12? I have some common factors, right? 4, so we can divide top and bottom by 4. So 1/6 equals question mark. What's 8 divided by 4 is 2 over 3. Those are not equal. Not equal. What does that mean? That means that 1 is not a solution to this equation. All right. Any questions about that one? All right. Okay, so let's go to part B on your own. We're down at page 116 still. We have part B here. We have is 1/2 a solution to 5x minus 1/4 equal to x plus 3 over 2. All right, guys, what's my first step here? Can somebody tell me what my first step's going to be? Lowest common denominator. That's probably going to be our next step, but before we get there, we need to replace x with 1/2, right? But I think you're right. I think we are going to have to find a lowest common denominator or the least common denominator after that. We have to put this in for x. So let's do 5 times 1/2 minus 1/4 equals question mark 1/2 plus 3/2. Okay. So on this side, we have 5 times 1/2. Remember, that's the same thing as saying 5 over 1, and we just multiply across. So we get 5 over 2 minus 1 over 4 equals question mark. What's 1/2 plus 3/2? Remember, we just add across the top, right? That's 1 plus 3 over 2. Everybody okay up to this point? Yes, okay, good. Thank you. All right, so you're right now, Joy. On the left side, we do need to come up with a least common denominator, right? 2 is a factor of 4. That means that this is our least common denominator on this left side. So to make the 2 a 4, I have to multiply top and bottom by 2. So now we have 10 over 4 minus 1 over 4 equals question mark. And this 1 plus 3 gives us 4 over 2. All right. Let me erase a little bit of this so that we have a little bit of work room. Come back up here. So now we have, what's 10 fourths minus 1/4? That gives me 10 minus 1 on the top and 4 on the bottom. Equals question mark. And 4 over 2 is just 2. Remember, 4 divided by 2 is just going to be 2. So now we have 9 over 4 does not equal 2. Eesh, it was close, but it's not there. If it was 8 over 4, it would both be 2, but it's not. So that means that this is not a solution. Does anybody have any questions about how to do this? Like I said, this is just like what we did when we did it with integers. We're just now using our tools that we've used about least common denominators, adding, subtracting fractions, multiplying and dividing fractions. Not yet. Good. That's good. No news is good news. All right. So the next thing we're going to talk about is how to solve fraction equations using several steps. So I'm just going to introduce this. We're not going to have time to fully talk about it, but we will introduce it so that we can pick it up on Tuesday of next week. So fraction equations fall into two main categories: the type where we clear a single fraction as a final step, and the type where we clear all fractions as a first step. Here we will solve the first step, where we clear a single fraction as a final step. We'll work with clearing fractions as a first step in the next objective. So the multiplication property of equality is used as a final step to isolate a variable that has a coefficient other than 1. For example, in the equation 4x equals 8, we divide both sides of the equation by 4 to get x equals 2. Notice that we would get the same results if instead of dividing by 4, we multiplied by 1/4. We'll see why this is important in the next example. Do you guys remember, I said, I know, I probably bored you guys or you weren't listening, but a long time ago, I kept saying, really, when we're multiplying by a number, it's the same thing as dividing by that, or when we divide by a number, it's the same thing by multiplying by its reciprocal, or I said there's really no such thing as division, it's the same thing as multiplying. This is what I was getting at. When we say divide by 4, that's the same thing as saying multiplying by 1/4. So here, let's look at solve 4x equals 8. So on the left side, we're going to look at it as dividing by 4, and on the right side, we're going to look at it as multiplying by 1/4. They're the same thing, but we're going to show you why in a minute. So 4x equals 8 is this, when we solve it, we divide both sides by 4, right? We have 4x over 4 on the left side, 8 over 4 on the right side. Those 4's cancel, and then 8 over 4 becomes 2. So then we end up with x equals 2. On the right side, we're going to say multiply by 1/4. So 4x equals 8. We're starting with the same equation. We're going to multiply 1/4 times 4x and 1/4 times 8. Again, it's the same thing. Those 4's cancel, and that 8 divided by 4, or 8 multiplied by 1/4, gives us 2. So we have x equals 2. Multiplying by the reciprocal of a fraction coefficient clears away the fraction and isolates the variable. This is really important, so please make sure you understand this. 2/3 x equals 7/8. Instead of doing like dividing by 2/3, we're going to multiply by the reciprocal. 3/2 times 2/3 equals 1. And this is why, let me just show you really quick. So we have 2 over 3 times 3 over 2. It's the same thing we just talked about. 2 times 3 over 3 times 2. Remember, 2 divided by 2, you're going to get the ones, right? Those common factors. So it's really important to understand, instead of, if we have 4x, instead of dividing by 4, we're now just going to multiply by the reciprocal to clear that fraction. So now you have to multiply both sides by 3/2. So we have x equals, and then 3 times 7 gives us 21, and 2 times 8 gives us 16. So some equations need to be simplified before the multiplication property can be used. In the example problems, we will follow the process for solving linear equations using both the addition and multiplication properties. So we're going to get there, but it's really important that you guys understand this. Okay, so we're gonna go ahead and leave off there for the day. But what I'm going to do is, for those of you that think you might understand this, I'm going to go ahead and give you the practice problem for 4.9. If you have no idea, don't even begin looking at this. But for those of you that see this and go, oh, I think I can do that. Let's go ahead, and you've got 4.9 problems: 9, 15, 21, 27, 31, and 41. So on Tuesday, we are going to, I got Joy, I got that. On Tuesday, we are going to finish 4.9 and we're going to start 4.10. Okay. So you guys need to finish your Module 9 quiz this weekend. We will be working on the Module 10 stuff next week. We'll finish that so you guys can finish up that quiz next week. All right. We're trying to catch up so that I can make sure we cover everything for the final exam. So does anybody have any questions for me before I close this for the day? No. Okay. Sylvia, if you want to talk to me, go ahead and exit out and then go right back on, okay? Or I'll send you another link for a different meeting. So just go ahead and peel off and just look at your email in just a minute. So Sylvia, did you still want to talk after this? Yes, okay. I'm gonna send you a link. Just go check your email. Okay, sounds good. All right.